Here we have a problem on logarithm. That is, we have to solve for x in the given logarithmic equation. Okay, now let me start solving. Let me write the first term. That is log base 4 of x square positive x. And also we can notice an important thing in the given logarithmic equation. Here on the left side, we have two logarithms. One is over here, other one is over here. The first logarithm is having the base 4, but the second one is having the base 16. Okay, if I want to simplify the expression we have on the left side, both the logarithms must be having the same base, but here the bases are different. So our first work is to make the base same. So for that, what we have to do is we have to consider the second base. We have over here 16. Actually, it is a power of 4. That is 16 can be written as a 4 square. Let me write it. Negative 2 times a log. This base 16 can be written as a 4 square. And we have the argument x positive 1. On the right side, we have 2. Then we have a log base 4 of x square positive x. Okay, negative 2 times. Now, the base of the second logarithm over here is a power. Whenever the base of a logarithm is a power, the exponent we have at the base can be taken in front of the logarithm. When I take this exponent 2 in front of logarithm, it will become its reciprocal. That is, the 2 will become 1 over 2. That is 2 times 1 over 2 log. Since we have moved this exponent 2 in front of the logarithm, we just have base 4 over here. That is log base 4 of x positive 1 equals to 2. Okay, here this 2 will cancel out. Then I'm getting log base 4 of x square positive x negative 1 times logarithm is logarithm log base 4 of x positive 1 equals to 2. Okay, now I have the same base for both the logarithms, and here the two logarithms are in subtraction. Whenever two logarithms are in subtraction with the same base, what we can do is we can use the coefficient rule of logarithm. Coefficient rule means for these two logarithms, I can take just one logarithm with whatever base I have for these two logarithms, and I have to divide the arguments. That is, I have x square positive x over x positive 1. This is called the coefficient rule of logarithm. On the right side, we have 2. Okay, now what I'm going to do is I'm going to convert this logarithmic equation to exponential form. When I want to convert a logarithmic equation to exponential form, I have to consider the part which contains logarithm. Here we have logarithm on the left side of this equation. Okay, now what I have to do is I have to move this logarithm along with this base 4 to the right side of the equation. When I move this logarithm along with this base 4 to the right side of the equation, I have to ignore the logarithm. I have to consider only the base 4 on the right side of the equation. The value which already exists on the right side of the equation will become the exponent of this base 4. Then we get 4 square. Now on the left side we have this stuff, that is x square positive x over x positive 1. Okay, now we have x square positive x over x positive 1 equals to the evaluation of 4 square is 16. Now let me multiply on both sides of this equation by x positive 1 to get rid of the denominator over here. Okay, let me multiply on the left side by x positive 1 and right side also by x positive 1. Let me do it. So this x positive 1 will cancel out. I am getting x square positive x on the left side. On the right side we have to distribute this 16 to x and positive 1. Then I am getting 16x positive 16. Okay, now we have a quadratic equation in the variable x. Okay, to solve this quadratic equation for x, we have to get this quadratic equation standard form, that is ax square positive bx positive c equals to 0. That is, we have to get everything on one side of the equation. On the other side we must have 0. Okay, now let me make the right side of this equation 0. For that we have to get rid of this two terms of 16x and positive 16. For that we have to subtract 16x from both sides, and also I have to subtract 16 from both sides. Let me do it. So when I do so, this positive 16x, negative 16x will cancel out, and the positive value over here, negative value will cancel out. Then I'm getting x square. When I combine this positive 1x and negative 16x, I'm getting negative 15x, and here we have negative 16 equals to, on the right side we have 0. Now we have this quadratic equation in standard form. That is, we have everything on one side of the equation, and the right side 0. I think this quadratic equation can be solved by factoring. For that, we have to multiply this constant of negative 16 by the coefficient of x square. In this case, it's just 1. So when I multiply this constant of negative 16 by the coefficient of x square 1, I'm still getting negative 16. Now I have to get two factors for this negative 16, so that the sum of the two factors is equal to the coefficient of x, negative 15. I think negative 16 and positive 1 will work. When I multiply negative 16 and positive 1, I'm getting negative 16. When I add negative 16 and positive 1, I'm getting negative 15, which is a coefficient of x. Now we have to divide both these factors by the coefficient of x square, that is 1. So even when I divide these two factors by 1, I'm still getting negative 16 and positive 1. Now to get the two values of x, what I have to do is I have to change the signs of these two factors. So it's negative 16. If I change the sign, I'm getting positive 16. So that is one of the values of x in this quadratic equation. Now to get the second value of x, I have to change the sign of this factor. So it's already positive 1. When I change the sign, it will become negative 1. Okay, now I got two values for x. One is x is equal to 16 and the other one is x is equal to -1. So when we solve this kind of logarithmic equations, in the final step, the values we get for the variable always have to be verified with the given equation, because all the solutions we get at last cannot be considered as a valid solution. So they have to be verified. Okay, now let me verify the first solution 16. When I plug in x equals to 16 over here and here, so the argument in this logarithm, argument in this logarithm are positive. So we know that the argument of any logarithm can never be 0 or less than 0. Always it has to be positive. When I plug in the first value of x16 for x over here in this argument, both the arguments are positive. So we can consider this x equals to 16 as a valid solution. Okay, now let me take the second value of x, that is x equals to -1. When I plug in x equals to -1 into this argument, so what will happen now here? -1 positive will become 0. So this argument becomes 0. The argument of a logarithm cannot be 0. If the argument of a logarithm is 0, then it is undefined. So this value of x makes one of the arguments in the given equation as 0. So we cannot consider this is a valid solution. So there is only one valid solution, that is x equals to 16. Therefore, the solution for the given equation is x equals to 16.